Hi and welcome to another Dash Academy video. In this video, you are going to be learning about latitude, longitude, lines of constant latitude, lines of constant longitude, and you're also going to learn how to locate points on the Earth's surface using latitudes and longitudes. Before delving deeper, it is important that you understand that the following assumptions are being used. 1. It is going to be assumed that the Earth, the planet Earth, is a perfect sphere. So this shape here, representation of a 3D object, this blue shape here is known as a sphere. And we're also going to approximate the radius of the Earth as 6,400 kilometers. And just one key thing you need to note about a sphere is that the distance from the center of a sphere, so imagine, I just showed this outline. So imagine this is the center of the sphere. Distance from the center of the sphere to any point on the surface of the sphere is always equal to the radius of the sphere. So from this point to that point, this length of that line or the distance covered will be equal to the radius. Same thing if you go from this point to just any point on the surface of the sphere. I can imagine it's hard to fully picture point on the surface as distinct from points within the sphere in this diagram, but I just wanted to imagine that this central point is at the center of the 3D object, the sphere, and I'm drawing lines to point on the surface of the sphere. And what I'm telling you is that the length of such a line, or the distance between the center and a point on the surface of the sphere, is always equal to the radius. So just keep that in mind. That's going to be useful in subsequent videos. We're interested in pinpointing the exact location of points on the Earth's surface. So on the surface of our model of the Earth, which is a sphere. And you need lines of latitude and lines of longitude to do that. Now, as you can see here, a line of latitude is also known as a parallel, but the latitude of a point tells one the northern or southern position of that point relative to the equator. And the equator is just a circle that lies in the middle of the sphere. So that's the equator. It's just this circle here. Now, lines of latitude are the following small circles, and they just lie above and below the equator. So I think I should make a distinction between the equator and the other circles. So I'll just use a different color for the equator. I'll just use red. So I'll draw other lines of latitude. So, by the way, the equator is also a line of latitude. So all these black dotted circles go around the surface of the sphere. And since we're interested in points that lie on the surface, you know that some points will lie on these circles. They could lie on any of the points on the circle. Lie on any of these points, and on the other side of the sphere, these points could lie on the surface of the sphere. At these points I'm noting. Now, this is the equator, this red dotted circle, and what a line of latitude tells you is literally how far up north or how far down south from the equator the point lies. So it could tell you whether a point lies somewhere on this circle, somewhere on this circle, or somewhere on this circle, or somewhere on this one, or somewhere on this circle. So that's what a line of latitude tells you. So it tells you, okay, your point is somewhere on this circle, and that's useful to know. And when we go on to lines of latitude, you see how that helps us to pinpoint exactly a location on the Earth's surface. But moving on, more specifically, the latitude of a point P on the Earth's surface is the angle formed between the line OP and OQ, where point O is the center of the Earth and point Q is the point on the equator that lies directly below P. What does that mean? I'll just show you. So I'm just going to draw the equator again. So that's the circle that's at the middle of the sphere. The center of the sphere, center of the Earth, is obviously going to be the center of this equator. So I'm going to call that center O. I'm just going to randomly locate a point on the Earth's surface. I'm going to call that point P. Now, this point P lies on some line of latitude. So I'm just going to show you. Lies on some line of latitude. I'll just show you that. Now, what I'm saying is the latitude of point P is given by the angle formed between this line OP and the line formed between point O and a point Q, which lies directly below P. So that's Q. The line of latitude is this angle. So I'm going to show you. So this is the latitude that P lies on, and this is the equator. So say we have point P somewhere here, point O at the center here, and this is a line there, and then there's a point directly below P, I'm calling that point Q. The latitude of point P is given by this angle. The angle formed between the line OP, so the line from the center to the point P we're interested in, the angle from between that line and the line OQ, where Q is just the point directly below P. So the latitude of a point is an angle. The latitude of a point is an angle, and a line of latitude is a line that is such that is made up of all the points with the same latitude. You'll learn more about this shortly. But so a line of latitude is the same thing as a line of constant latitude. Any point on this line of latitude is such that when you draw a line from the center to that point, so I'll call this point P2, and then you locate the point directly below that point, so I'll call this Q2. The angle formed between O, in this case OP2 and OQ, this angle theta is the latitude, and it's going to be the same regardless of which point you use. Now this is easier to visualize if we had a 3D model of the Earth, and just we could just show things in 3 dimensions. Well, I can't do that here, but the key thing I'm trying to stress is that a line of latitude is such that all the points on a line of latitude or a line of constant latitude have the same latitude, and that latitude is an angle, and that angle is given by the angle formed between a line from the center of the Earth to that point and a line from the center of the Earth to a point directly below the point we're interested in, but which also lies on the same plane as the center of the Earth. You see what I mean? So that's a bit complicated, but just key thing to take away is a line of latitude is a line that is such that it contains all the points with the same latitude, and the latitude is an angle, and the latitude of a point tells one how far up north or how far down south from the equator a certain point lies. So let's try and further understand how to determine the latitudes of points. So imagine the point on the surface of the sphere of the Earth, and it lies on a certain line of latitude. I'll just show that in green or white. So it lies on this line of latitude. So this point, I'll call the point P, and we have the equator here at the center of this sphere. So it's just a circle, and this is just a rough sketch. Now, to determine the latitude of point P, all you have to do is locate the center of the Earth, draw a line from the center to this point, locate a point directly below this point P, call that point Q. Now, this angle here is the latitude of point P. So for instance, let's say this angle was 70 degrees. That means that point P has a latitude of 70 degrees north. Now, the north is there to tell you that point P is to the north of the equator, and such that this angle I just showed you 70 degrees. Now, if we had another point somewhere on this latitude, this is a latitude, a line of latitude, and it lies to the south of the equator. So let's say we have a point, I'll call this point P1. Now, all you have to do is draw a line from the center to the point P1, locate a point directly below P1, which is probably some point here, so it's going to get a bit messy. Let's assume Q is also directly below. Okay, I wouldn't do that because it doesn't look so good, but let's say a point here, so I'll call that point Q1. It's just directly, well, below P1 or above P1 in a sense, above Q1. The main thing is this point Q1 is on the same plane as the center, so it's on the same plane as the equator. All you have to do is find the angle between the line OP1 and OQ1. So it's just the angle formed here, this angle here. And say that angle is, let's say it's 60 degrees. It means that the latitude of point P1 is 60 degrees south. So you always have to note down whether the line of latitude that the point lies on is to the north or to the south of the equator. So here's another point on the surface of the Earth. I'm going to call this point P2. If you wanted to determine the latitude of this point, all you have to do is, well, locate the center of the Earth. So let's say this is the equator. Circles are really hard to draw, so I'm just trying my best. And all you have to do is draw a line from the center to the point, locate a point directly below that point that's on the same plane as the equator, so call that point Q2, and all you have to do is find an angle between OP and OQ. So this angle here will tell you the latitude of this point P2. Now the line of latitude that P2 lines on is something like this line, and all points on this line of latitude will have the same latitude at this point P2. But if, let's say, this angle was, say, 60 degrees, or let's say 65 degrees, okay, that's hard to see. It just means that the latitude of point P2 will be 65 degrees north. Why north? Because point P2 lies to the north of the equator. If we had another point, I'll just look at the point. So this point is point P3. It lies on some line of latitude, so you can imagine a line on some circle that goes round, and lies on the surface of the sphere. To determine the latitude of point P3, all you have to do is draw a line from the center to the point P3. So a straight line from the center to P3. And locate a point, since P3 is to the south, a point directly above P3. That's also on the same plane as the equator. So point directly above, in this case. And I'll call that point Q3. So that should be a straight line. And the latitude of point P3 is simply given by the angle formed between the line OP3 and the line OQ3, which is this angle here. Let's say this angle, I just wrote theta there. Let's say that angle is an angle of 80 degrees. The latitude of point P3 will be 80 degrees south, because point P3 lies to the south of the equator. So I should alter the definition here. When I say where Q is a point on the equator that lies directly below P, it should be below or above. It depends on position of the point. Now Q lies directly below P when point P is to the north of the equator, but Q lies above P when the point P is to the south of the equator. So it's directly below or above. So the other thing we need to determine, to pinpoint exactly the location of a point, is a line of longitude. So we're going to focus on lines of longitude, also known as lines of constant longitude. These are also known as meridians. And these are half great circles. And what does that mean? A great circle is simply a circle that's a cross section of a sphere that has a diameter equal to the diameter of the Earth. Let's put it that way. You don't really need to worry about this technical term, half great circle. But the key thing is a meridian is a half circle. So it's something like this, half of a circle, or this, it's half of a circle. And it runs from the North Pole to the South Pole. And also it connects points with the same longitude. Hence why it's known as a line of constant longitude. But I like to use the term meridian because it's easier. It's fewer words, fewer letters. It's faster to say. So, of course, the North Pole lies somewhere at the top tip of the sphere, and the South Pole lies somewhere here. And an example of a line of longitude would be just any line that is a half circle that runs from the North to the South Pole. So these are important lines of longitude. The one that passes through the line of longitude that passes through Greenwich in England is known as the prime meridian, and it's the 0 degrees. Essentially, the longitude of every point on that line is 0 degrees. Notice there's no east or west there because it's the reference point for other lines of longitude. Now, the line of longitude that contains all points with a longitude of 180 degrees east is the line that lies to the east of this prime meridian. So I'm assuming this is a prime meridian. The line of longitude that lies to the east, but 180 degrees to the east. So one will have to actually rotate 180 degrees to the east to get to that line, and it's somewhere in the back there. But the line of longitude that contains all the points with longitude of 180 degrees west lies 180 degrees to the west of this prime meridian. And the funny thing is that this line of longitude and this one coincide, because 180 degrees in this direction and 180 degrees in that direction leads to the same point. Key thing now to note is that the longitude of a point on the Earth's surface is the angle between the prime meridian and the longitudinal plane passing through the point. So saying this is a point, and this is the line of longitude that this point lies on. I'll use a different color. Again, all lines of longitude run from the North Pole to the South Pole. So now, if I'll just put it this way. If I start at this point here and I move along a circular path, I will cover a certain angle whilst moving from here along a circular path to this other meridian. So if I move from the prime meridian to this meridian, the line of longitude for this point P, I'll cover a certain angle because I'm rotating. So let's say this is central point. I'm covering a certain angle. That angle I cover is the longitude of this point P. And in this case, let's say this angle is 40 degrees, for instance. The longitude of point P will be 40 degrees east. Why? Because this line of longitude, or point P rather, lies to the east of the prime meridian. So I have to move an angle of 40 degrees to the east to get to the line of longitude that contains point P. Let's say this is the prime meridian. Let's say this is the prime meridian, so longitude 0 degrees. And there's a point here. Let's call that point A. And it lies on another meridian, another line of longitude. Of course, running from the North Pole to the South Pole. But you get the idea. Now, the longitude of this point A is given by the angle formed at the center of the Earth if one moves along a circular path from this prime meridian to the line of longitude that point A lies on, is the angle formed at the center of the Earth. So I'm just going to roughly locate the center there, even though it's not there. The key thing is just to note that it's the angle formed as one rotates from the prime meridian to the line of longitude containing point A. And this angle here could have any value. So let's say I'll call this angle theta, and let's say theta is 100 degrees. The longitude of point A will be 100 degrees west, because point A lies to the west of the prime meridian. Now there could be another point 100 degrees away from this prime meridian, and I'll call that point B. So let's say, again, I just located the center there, even though that's not the center, but let's say that was the center. So the angle formed as one moves from the prime meridian to the point B, the angle formed at the center of this sector I just formed is the longitude of point B. So let's say this angle is also 100 degrees. The longitude of point B, I'll just write 100 degrees here. Now there's just not enough space there. The longitude of point B is 100 degrees also, but 100 degrees east because point B lies to the east of the prime meridian. Now this is a rough sketch, but the key thing I'm trying to stress here is the longitude of a point tells you how far to the west or to the east of the prime meridian that a certain point lies, whereas the latitude of a point tells you how far to the north or to the south of the equator that a point lies. That's just a key thing I'm trying to stress here. And just one more thing to notice, that latitudes of point only vary from 90 degrees north to 90 degrees south. So you can have latitudes ranging from 0 degrees to 90 degrees north, so 0 degrees, 30 degrees north, 60 degrees north, up onto 90 degrees north, or from 0 degrees down to 90 degrees south. You can have a latitude that's larger than 90 degrees south or larger than 90 degrees north. But for longitudes, they vary from, you can go from 0 degrees, that's the prime meridian, to 180 degrees west, or from 0 degrees, if you move in the eastern direction, 0 degrees to 180 degrees east. So there's a line of longitude where all the points have a longitude of 180 degrees west. There's also a line of longitude, or rather a meridian, on which all the points have a longitude of 180 degrees east. So like I said, a meridian is always a half circle from the North Pole to the South Pole. So I'm just going to randomly draw a meridian. Now, key thing to notice that there are many points on the surface of the Earth that lie on this meridian. And all these points have something in common. They have the same longitude. And the longitude is an angle, and it tells you how far to the east or west of the prime meridian that point lies, or the meridian that the point lies on. So let me put it this way. Let's just say that's the prime meridian. So all points on that line have a longitude of 0 degrees. One moves, and let's say that's the center. Here's what I'll do. I'll locate the center of the Earth here and draw a vertical line. I'm trying to avoid using planes because it can get confusing. But let's say that's the center of the Earth, and this is a point A, and this is a point B. Now we're interested in point B, and this is just a point A that is, I'll just have to say it, on the same plane as point B. If one moves from point A to point B, and let's say this central point is not necessarily the center of the Earth, but it's on this line that passes through the center of the Earth. So what I've formed here is a sector, and I'll draw it over here. So point A lies on the prime meridian. Point B is the point we're interested in. It lies on another meridian. Now, the longitude of point B is the angle formed at the center of this sector when moving from the prime meridian, a point on the same plane on the prime meridian, to the point B. And that angle is just the longitude. This introductory section is going to seem confusing, but when we go and deal with examples, things will make more sense. But the key thing I'm just trying to let you know is that it's the angle formed between the prime meridian and the meridian that the point you're interested in lies on. And it's an angle formed at the center of a sector which lies on the same plane that the point you're interested in lies on, and the point you're starting from on the prime meridian. A good way to explain what I was just saying is as follows. Imagine, so you're just going to have to accept my rough sketch. Imagine this is a sphere, and this is a point B that lies on the surface of the sphere. Now imagine if I cut through this sphere. I just cut through, so get a slice of the sphere, and I'm left with this shape. So it's sort of a, well, it's not a hemisphere, but it's sort of a hemisphere, but it's not necessarily a hemisphere because point B just lies somewhere in the sphere, not necessarily at the center, but don't worry about that. So point B is a point on the surface of the Earth. I just cut the Earth into two parts, and this is point B here. Now, on this plane here, this is what I mean by plane. So I'm just going to have to use plane because that's the best way to explain it. On this plane lies a point here. I'm going to call that point O, and it's the center of the plane. And if imagine the center of the Earth was somewhere here, the North Pole is directly above. There's a line that passes through. Now, this point O lies somewhere on this line. Yep. So now, imagine that we have the prime meridian here. Just imagine that's the prime meridian. There's a point that's on the same side of the surface of this sphere. I'm going to call that point A. And that point will be somewhere here. This point A lies on the prime meridian. And the idea is to measure the angle between the prime meridian and the meridian that point B lies on. And the way you do that is you just form a sector, and as you move from point A to B along an arc on that same plane, the angle formed at the center is the longitude of point B. And that angle is the angle between the prime meridian and the meridian of point B. And that angle is the longitude. And let's say this angle was an angle of, let's say, 80 degrees. It just means that the longitude of point B is 80 degrees east. Why east? Because point B lies to the east of the prime meridian. The prime meridian would be something like this. So they've gone like that. This all makes sense when we get into the example, but this is just a way to introduce you to the idea. So I had to cut this sphere into two parts. This is just one of the parts, and the key thing is this is a plane, and there's a central point of this circular cross section, and a sector is formed between this central point, the point B we're interested in, and the point A, which lies on the prime meridian and also on the plane of this cross section. Now this sector is what we use to determine the longitude of point B, because all we have to do is find the angle formed at the center of the sector. And as I say, angle formed as one moves from this point A on the prime meridian to the point B on its own meridian. And we're just interested in finding the angle between the prime meridian and the meridian that point B lies on. So this is a way of doing it, and that angle we get is the longitude of point B, which I just gave 80 degrees as a random number for the angle, a random value for the angle. And the key thing here is that it's 80 degrees east because point B lies to the east of the prime meridian. Here's another sphere, or a rough sketch of a sphere. Here's a point. I'm going to call this point A. This point lies on the surface of the sphere, and we want to determine the longitude of that point. So what do? You literally slice along the latitude that the sphere lies on. So you slice in a horizontal fashion. So it gives you something like this. When you slice the sphere, or the Earth rather, and point A will be somewhere here. Now, the prime meridian, assuming that the prime meridian is this line here, so that's the North Pole and the South Pole, and the center of the Earth is, let's say, this point O here, and of course there's a line that runs from the North Pole to the South Pole, which passes through the center of the Earth. So that line is a line that divides the sphere into two parts as well. But imagine that on this plane that point A lies on, there's a point here. I'm going to call that point, I'll call that point OA, just to refer to the fact that the point OA lies on the plane of point A. So imagine that's the point here, and that point is at the center of this circular cross section here. You know, I just sliced this sphere into two parts. So this circular cross section, the center is this point OA, and there's a point on the prime meridian, which is this point here. I'll call that point B, and that point lies on the same plane as point A. So you know what I mean by plane now. Now if you form a sector, there's an angle formed at the center, and since point B lies on the prime meridian, you think of a motion from the prime meridian to the meridian of point A as one involving an angle equal to the angle formed at the center, and that angle I'll call it theta. So I'll just give you the sector here. So imagine this is the point OA, so that's the center of the circular cross section that point A lies on. So it's point B, point A. Point B lies on the prime meridian. So I'm saying this point here, this line here, is the prime meridian. Now the angle formed as one moves from prime meridian to the meridian that point A lies on is this angle here, and that angle here is the longitude of point A. Remember, the longitude is an angle, and it's the angle formed between the prime meridian and the meridian that the point you're interested in lies on. So it's this angle theta here. Let's say this angle theta was equal to 30 degrees. So that should be 0. So it's equals 30 degrees. What is the longitude of point A? The longitude of point A is simply 30 degrees west. Why west? Because point A lies to the west of the prime meridian. It's as simple as that. I know the whole idea of cutting the circles and getting cross sections could be confusing, but as we move on to examples in a subsequent video, you'll get used to this and it'll make sense. So I guess the key thing now I'd like you to take away at this point is just to know that the longitude of a point tells you how far to the west or to the east a point lies from the prime meridian. But a latitude is an angle, and it tells you how far to the north or south of the equator that the point you're interested in lies. Those are the key takeaways so far. Now that you have a good idea of what latitudes and longitudes are, we're going to locate points on the Earth's surface using given longitude and latitudes. So this is a point here. I'll call this point point A. It has a longitude of 60 degrees east. So if this North Pole, South Pole, if this is the prime meridian, point A is on a meridian that is 60 degrees to the east of the prime meridian. So I'm going to use a different color. I'll use white. 60 degrees to the east, so we won't have to move, well, 60 degrees to the east. But another thing to note is that point A lies on latitude 0 degrees. Now note that I didn't use north or south for the latitude. Latitude 0 degrees simply refers to the equator, because that's 0 degrees from the equator. So let's say the equator is somewhere here. Point A lies somewhere on this circle, the equator, but it's on the meridian at 60 degrees from the prime meridian. So 60 degrees, let's see, so we're on this latitude, or somewhere along this line. So if you move 60 degrees, you'll land somewhere here. So point A is somewhere here, and that means the angle formed, the center is somewhere, well, there. Now it's hard to see the sector properly, but the key thing is just the angle formed at the center of the sector would be 60 degrees, and that's the longitude of point A, and the latitude of point A is 0 degrees, which is why it lies on the equator. So that's point A for you. That's point A. Now latitude 90 degrees north. I'm just going to focus on this point. I'll leave this point for you to try at home. Latitude 90 degrees north is the North Pole. 90 degrees from the equator to the north takes you to the North Pole. So this point, I call this point point C, has a latitude of 90 degrees north and a longitude of 100 degrees west. Well, the longitude doesn't really matter because the North Pole is actually a point. So regardless of, and so many longitudes pass through the North Pole. So many longitudes pass through the North Pole. So any point that has a latitude of 90 degrees north is going to lie at the North Pole. So point C is going to be here. So a similar thing will happen here, where this point has a latitude of 90 degrees south. Like a latitude of 90 degrees south takes you to the South Pole, and many meridians, lines of longitude, pass through the South Pole. So regardless of which line of longitude this point is on, so this point is on longitude 10 degrees east, which is 10 degrees from the prime meridian, it doesn't really matter, because at the end of the day it has to be on latitude 90 degrees south, which is the South Pole. So that point is going to lie here. So you can try and locate this point at home. All you have to do is locate the meridian that is 170 degrees to the east from the prime meridian, and you have to locate the latitude, which is just going to be a small circle that's parallel to the equator. You have to find the latitude that is 20 degrees to the south of the equator. So you know that that small circle is going to be below the equator, it's going to be to the south.